Hi, my name is Mina Johnson-Glenberg. I'm going to talk to you about design principles for online learning for this international workshop that's going to be going on at ASU. I'm also the director of the Embodied Games for Learning Lab at ASU. So this is a two-part lecture, and for the first part I'm going to define what I mean when I talk about learning, and I'll talk about some best principles for that. And in the second part, I'll show you a rubric for how to assess the quality of online learning objects, and we'll talk about some examples. So let's get started. What is learning? You could get a list from any learning textbooks on the components that make up learning. Art Gracer and his gang have one called the 25 Principles of Learning. Here's some of the examples, right? The testing effect, the spacing effect. If you space out your practice and your review for a test, you're going to do better than if you cram. These things are well-known tenets. Now, I've been trained as a cognitive psychologist, and I've sort of morphed into a multimedia learning scientist. My definition of learning and my take on how it can be best facilitated with computers is a bit different. For me, learning is synonymous with structure building. So that means we build structures in our minds as we understand content. Experts have very large and very flexible knowledge structures. You can think of these as Legos, right? Novices are those that are just beginning, so they have very little basis for a structure. I never took physics in school, right? So I had disparate notions, what DeSessa would call P-prims about physics. Perhaps I understood that a force was a push or a pull. It was sort of a jumble of unconnected blocks, right? So when I would see an equation like this for centripetal force, it was really this kind of ungrounded grouping of symbols. Sure, I knew that r was radius, but what was it doing at the bottom of this equation, of this fraction? So 5 years ago, I really knew nothing about centripetal force. I had this tiny little structure here. I was sort of like a Duplo chick, right? Closer to a novice than an expert. Very small structure. As I said, experts have these large structures that have multiple studs and recesses for more blocks to be added to. They can easily expand their structure. That's actually what the little nub on a Lego is called, a stud. I just learned that. This thing is 30 feet long. Also, when you think about learning, you can turn the microscope up or down, right? Some people turn the knob to the right, and some people turn the knob to the left to look at the grain size of learning. And I'm kind of a knob to the right girl. So learning for me is morphosynaptic. That means the synapses are changing. That definition is a little bit out of fashion. There's more emphasis on social aspects now and what happens in an entire classroom, and that's really important. But as a quantitative person, I really like to measure things. It's easier to measure the number of buttons on the ends of axon A and B post-instruction than it is to measure what's going on in an individual brain with 30 kids around after several hours of instruction. We as educators, though, are not actually able to do this sort of thing in vivo. And I'm actually also skeptical about some of the fancy rainbow movies that we get from the fMRI bold signal. So what is that telling me about an individual brain? In any case, those are not the tools that are available to us in this room. We have traditionally used paper and pencil, tests, and short essays. And so, again, what is learning and how do we assess learning? For me, learning is about changes in brain structures. And hopefully we can agree that these changes are very nuanced, that they're tiny, massively parallel, and highly individualistic, meaning that a person arrives to the task with a certain amount of prior knowledge, and we can't always know that as a teacher in a classroom or even someone who's giving a learning object as homework. How can we be creative in maximizing the efficiency of learning using computers? Because learning is nuanced, and it's also nonlinear, non-monotonic, and discontinuous, we have to be really aware that it is hard to measure and hard to teach sometimes. So this is a very famous example of syntax, right? Little kids say went, and then they overlearn the ED rule and they say goed, but then as they get older, they go back to using went again correctly. So that's what I mean by non-monotonic, non-linear. So here's a vocabulary primer for designers. By all means, be familiar with those 25 principles that you can find in the books, but I actually recommend that if you had to keep two in mind as you were designing your learning modules, you would really strive to make them be collaborative and generative. So what do these words mean? Collaborative means that two or more people are working together on a problem. Because we're also instructional technologists here, we assume there's always a computer present, and that computer could be a large interactive whiteboard display, or it could be individual tablets where students are talking back and forth with each other, or there could be an agent embedded in the tablet that makes you feel collaborative. Content should be designed for two or a group to collaborate on a problem simultaneously. Now, as you build that, you need to build in space for discourse and pauses for reflection. And one of the things we have to be aware of is how do we build in places and times for reflection without it feeling like dead time for some of the students. What does it mean to be generative? That term has a long history in cognitive science. And when I use it, I literally mean that the output created by the learner is generated. That means that it's the highest level. They're making it from their own brains. An inference has been constructed about what they've just read or done, and they tell you about it or show you it by moving icons around on the screen or typing out a text response. This is effortful, and effortful cognition is lasting cognition. New pieces are being added to the existing Lego structure in this way. I'll tell you what generative is not. It's not clicking on a true-false question, okay? Then you're only generating a motor response. You don't even know if the learner has read or is thinking as they do that with a 50% chance of getting it right. A better example would be, as I said, to make a learner write out original text to generate an answer with their own response, with their own words. And those can be scored with natural linguistic processing algorithms. So how should we in this room and watching this talk, how should we design multimedia lessons today? You can read Richie Mayer's work and others to see more principles, and those are very appropriate for static PowerPoint type lessons. There's also been a lot of focus on cognitive load, what that is, how to measure it, but I find it a bit abstract. It's hard to put into practice when you're designing lessons that are supporting the flow of learning. And now that we have so much animation built into these lessons, you know, how do those rules that we learned with static PowerPoint type lessons transfer to the more active and game-like lessons that are coming onto the market now? And because it's easy for users to self-pace. We have so many tools now to create animations. The past 3 years, there's really been a revolution in cost and availability of multimedia creation tools. Most of our students now expect more professional-looking graphics, better editing, and more generative prompts to be embedded into the content, and I actually agree with that, and we should deliver that. So I'm not going to go deeply into this study that we did on generativity and embodiment. I will just tell you that we had two conditions in the lab situation. One was low generation. The students were learning about centripetal force. And in this low generation, low embodied condition, they would merely start or stop a simulation on centripetal force. Whereas in the high embodied generativity condition, they would be inside a motion tracking platform and able to spin the object around, and then they would feel the pull of centripetal force on their body as the object or the bob was swung overhead, as you can see in this movie. Now, the results of this study, I can go over them in the face-to-face session, but I'll just tell you now, I'll just jump to the point that the results supported an increased retention of physics knowledge when the participants were in the high embodied, high generativity condition. We didn't see those differences immediately post-test, but when they came back a week later, then we saw this retention of the knowledge, and that's what teaching is about, right? Retention of knowledge. Okay, but you're not here to hear about fancy motion capture platforms. What you want to hear about is perhaps, I'm hoping you want to hear about, a more standardized way to design for, to discuss, and to quantify the quality of learning objects on more traditional interfaces. Because online learning is different. It's different from books, it's different from lectures, and even from the film strips of yore. Do you remember how film strips and TV were supposed to revolutionize learning? So we'll call the film strip people Generation Zero, right? And I'm of that generation. Well, I was a student in the class in the 70s when they would roll these clanky projectors into the classroom, fumble around for 20 minutes, threading them up. These short films always started with a non-interactive talking head, a bit like me now. And then they would toss in some static images, and there would be text at the bottom, and some basso profundo voice would say, "This is a chlamydia bacteria." Afterwards, the teacher would turn it off and then make some profound observation like, well, I grew up in the Deep South, so she would generally say something like, That there's chlamydia, and if you look at someone of a different sex, you will get it all over your body. So don't look at someone of a different sex until you're married. And then once a month you can look at them. Class dismissed. All right, that was Generation 0. Generation 1 had scanned textbooks. And now I would say that we're in Generation 2, right? So what can Generation 2 do? Oh my word, we can just add it all, right? We can put animations in there, we can put blinking arrows, we can fill in the query with only the first 2 letters, we can collaborate, we can have generativity, we can have it all, but really, should we have it all? So what does an efficacious learning object look like now that we have so many tools at our disposal? How do we answer the question of efficacy in a multimedia lesson, which I call learning object? Which parts are overwhelming? What has been the traditional gold standard for a 1 degree of freedom experiment? So how do we answer this? If you were in the classroom, I would pause here and some intrepid student would raise his or her hand. But I will just go and tell you that the gold standard is a randomized controlled trial. So we would assess which single variable affects learning above an arbitrary p-value of 0.05. Can this be done in an ecologically valid manner for learning objects in a classroom? Can you really alter, with 1 degree of freedom, what's going on in a lesson in a messy classroom environment? That's hard, perhaps impossible. But we really do, as learning scientists, have to put a stake in the ground at some point. And I have doubts sometimes about transfer from a lab situation to a classroom. But at some point, you take the plunge and you look at the components that make learning effective. So I'm going to talk to you about an article that came out a few years ago that really looked at these 2 ideas of collaboration and animation. It's from Rebouté, and the title is Learning from Animation Enabled by Collaboration. So putting animations in a learning object should make learning easier, right? Especially if it's dynamic, moving content. And I'll ask when I see you why you think this might be. What are some hypotheses that might support the idea that adding an animation would be helpful? And is there any reason why it would not be helpful? The primary question addressed in this article is, how does collaboration alter the learning dynamic? How might having a learning partner increase or decrease retention? And what would be your predictions about having a partner? How might having another person to discuss a concept with help or hinder understanding? Another forced pause here where you would type out your hypothesis and we could discuss it during the section. You could email it to me or to yourself. Maybe you're keeping track of all of these. So here's what they say in the introduction. Why and when it helps. It's really not a simple yes or no, okay? So they cite 3 potential effects in the introduction. 2 were positive and 1 was negative. So the 2 positive ones would be a facilitating effect that watching an animation would free cognitive resources. And the other is an enabling effect, particularly helpful for novices because an animation can portray both the coarse and the fine, the micro steps in a process. And here's one that they think might be negative about it, right? Because the changes do not have to be inferred. There's no effort expended. It leads to shallow processing. So if you have the animation in front of you showing everything that's happening, then you don't have to work hard. It's not effortful for you to understand it. You're not making the image yourself. The conceptual underlying dynamics of the system may not be integrated into the learner's knowledge structure. And we also know that people often think they understand things when they don't, right? So you're nodding your head watching the animation, you think you understand, but recall can be poor. This is related to what's called the underwhelming effect. Cognitive involvement is withdrawn because the hard work's being done for you. Rebouté et al., they say that collaboration should result in greater cognitive involvement for building and maintaining of shared representations. So this is one reason why they like to add collaboration as well, perhaps, as animations. They predicted that dyadic discourse would mitigate the underwhelming effect of animation because participants were instructed to explain what they had learned in the last step of the experiment. So there were 7 sections in this experiment. The design was quite elegant between subjects with 3 factors, 2 levels in each factor. The first factor was learning setting with a single person or a dyad. The second was whether a lingering snapshot stayed up on screen or not. And the third factor was type of instruction. Was it static with static images, or was it animated? The topic was Transit of Venus. Another topic was Rifts. The animation sections, again, there were 7 of them, varied anywhere between 8 to 35 seconds. They had multiple measures. I'm just going to skim over these. You can read this article if you're interested. Pre and post, a cognitive load assessment, that was the TLX, and elaboration time. So how long they paused after each sequence to, A, either reflect on what they'd read if you were in the single person condition, or B, dyads were instructed to explain what they had learned in the last step to their partner. Both people had to do that. There was no going backwards, but participants had control over the elaboration time. So what were their results? Significant overall difference seen between animated and static conditions. So the post mean for animated was 3 points higher. Significant interaction between animation and collaboration. So that such that the group that was collaborative and also saw the animations did significantly better. So that was an effect size of 0.87, large effect. And collaborators spent more time elaborating. The TLX showed that actually difficulty was similar across all conditions. So animations weren't harder, nor were they easier to process. So for the discussion, positive effects were seen for animation. However, for transfer of these implicit type questions, positive effects only seen for those in the collaborative dyads. Supports the idea that there can be an underwhelming effect for some individuals, but when additional cognitive processing is induced by the collaboration, the talking to each other, this allowed for construction of a more coherent, accurate mental model. It would be like being able to add more Legos to your structure and then maybe put glue on top of them so it stays stable. The take-home message, although collaboration may require more time, it leads to a more elaborated verbal information exchange, and this results in better performance on these inferential questions, the harder questions. As a designer, you're probably going to get the most bang for your buck when you include both animation and collaboration in your multimedia lessons. Okay, so that's the way I think about learning and the things you should be adding to your lessons. Next part of this, next section, I'm going to talk about a rubric for how you can quantify the quality of a learning object. Thank you.